Hi guys, this is Miss Franklin. We are going to learn about this thing called the zero product property. So zero, like the number zero, product, if you remember, product always has to do with multiplication. Just like sum is addition, product is multiplication. So let's go through some easy things that are going to lead us to what this property is all about. So 5 times 0, what does that equal? Well, that equals 0. All right. What about 0 times 5? What does that equal? Also 0. 0 times 0, also 0. So let's think about this. They all equal 0, but did both parentheses have to equal 0? Like when the first one, 5 and 0. There was only one parentheses that was equal to 0, and that meant the whole thing was equal to 0. All right, the second one, the first parenthesis was equal to 0, but the second parenthesis was not equal to 0. But still, the whole thing, when multiplied together, the product equaled 0. Okay, and then the last one, both of them equaled 0. So that makes sense. They equal 0. So let's think about what this all means. So basically what we're saying is in order for the whole thing to be equal to 0, either A has to be equal to 0, so either the first parentheses has to equal 0, or the second parentheses, B, has to be equal to 0. Now, could they both be equal to 0? Absolutely. But only one of them, A or B, the first parentheses or the second parentheses, has to equal 0 for the whole thing to be equal to 0. So that's what the zero product property tells us. Now, let's relate this back to quadratics. So I'm going to zoom, or I'm going to move on down a little bit. So it tells us that the zero product property can help us solve quadratic equations. And here are some examples. You may find that this looks very familiar from the second assignment from last week. So using the zero product property, either this first parentheses has to equal to 0, or the second parentheses has to be equal to 0. If one of those parentheses equals 0, the whole thing will equal 0. So let's do this. So what we do is we take the first parentheses and we say, okay, well, x minus 5, that could equal 0. We write the word or, and then we copy the second set of parentheses, x minus 3 equals 0. So one of those has to equal 0. So now we solve them. All right, so over here I need x by itself. So I'm going to add 5 to both sides. And I'm going to get x equals 5 because negative 5 plus 5 cancels out. Okay, so x could be equal to 5. Or, let's solve this one. I would add 3 to both sides, and I'd get x equals 3. Okay, so x equals 5, or x could be equal to 3. As long as one of those things is true, the whole thing will equal 0. So what does this mean if we put it on a graph? Well, let's take a look at this graph over here. All right, we have a quadratic equation. Well, where does it equal 0? Oh, well, it equals 0 right here at 3 and at 5. Those are what we call our x-intercepts or zeros. They're called zeros because that's where our graph is at 0, touches the y-axis.